Hello everyone. In this question, it is said that if a and b are two different positive integers and the two quadratic equations a minus 1 times x square minus a square plus 2 times x plus a square plus twice a equal to 0 and b minus 1 times x square minus b square plus 2 times x plus b square plus 2b equal to 0 have exactly one common root, then we are to find the value of a to the power b plus b to the power a upon a to the power minus b plus b to the power minus a. Okay. So first of all, the given conditions are that a and b are positive integers, right? So that means these are natural numbers and these are different, that is a not equal to b. Okay. And we are given two quadratic equations. The first one is a minus 1 times x square minus a square plus twice times 2 x plus a square plus twice a equal to 0, and another identical equation in b minus 1 times x square minus b square plus 2 times x plus b square plus 2b equal to 0. Okay, and we are given these two have exactly one common root. Okay, one common root. Okay, these are given conditions. So let us look at the first equation. Okay, the first equation is a minus 1 times x square minus a square plus 2 times x plus a square plus 2a is equal to 0. Okay, now can this equation be factorized? Okay, if we look at this expression x square minus a plus b times x plus a b. Okay, this is factorized to x minus a in times x minus b, right? So in other words, we have to see for this equation, the product is for this equation. Okay, the product ab is your this times this, right? Here the product of x square, coefficient of x square is 1. Okay, so 1 times ab is ab. Okay, so here the product is a minus 1 times a square plus 2a. Okay, so if we simplify it, we get a cube plus 2a square minus a square minus 2a. So this gives us a cube plus a square minus 2a. So if we take a common, we see a square plus a minus 2. Okay, so this further gives a times a plus 2 times a minus 1. Okay, so if I plug this a into either this or this bracket, okay, I can get two options of factors. One option can be a square plus 2a times a minus 1. Okay, I plug this a into the first factor. The other one is I plug this a into the other factor, a minus 1. Okay, then I will get a plus 2 times a square minus a. Okay, this is the product of this. Here whatever is ab here, this is the product, right? The coefficient of x square times the constant term. Okay, this is the product. Now the sum is your minus a square plus 2, that is your a plus b. This a plus b is equal to a square plus 2. Okay, a square plus 2. Okay, now in the general case, x square minus a plus b times x plus a b, you see the this term this a plus b is the sum of this a and b, right? If the product is ab, if the product of this and this, whatever the product is, the factors are these, right? A square plus 2ac times a minus 1 or a plus 2 times a square minus a. Okay. While middle term factorizing, whatever the products we get, factors we get, the sum of those two factors has to match this, right? Otherwise, it won't be factored. Okay. The product here is AB, and the sum of these two individual terms, this A and B, this A plus B is the middle term, right? So in our case, either this a square plus 2, either sum of these and this has to become equal to a square plus 2, or sum of these and this has to become a square plus 2. Otherwise, the factorization won't happen, right? So if we check with this one, the sum of these two factors, a square plus 2ic plus a minus 1, does it match this sum, a square plus 2? We see. Okay, we get a square plus 2a plus a will be 3a minus 1. So this one is not matching. Okay, now what about this one? A plus 2 plus a square minus a. The sum becomes a square, and this a and this negative a will cancel out, and we get a square plus 2. So this has matched this sum here. Okay, so this will be our factors. A plus 2 times a plus 2 times your square minus a. Okay, these are the two factors, a plus 2 times a square minus a. So if I factorize it now, this implies a minus 1 times x square. The factors are this, a plus 2 and a square minus a. Okay, so I can write it as a square minus a x minus a, a plus 2x plus a square plus 2a. Okay, so if I now middle term factorize it, let us see if there is anything further common that can be taken. In this term, we can take a common, so this will become a into a minus 1 times x minus a plus 2 times x. And from this last constant term, I can take a common again, and this becomes a times a plus 2 equal to 0. Okay, so this further implies if I take what can be taken common from these two terms, we can take a minus 1 times x. So from the first term, I have x left, and in the second term, a minus 1 is taken. A minus 1 times x is taken, so a is left out. Okay. Similarly, from the last two terms, if I take common a plus 2, what is left is your x, and since minus is taken common, we are left with minus a. Okay. So the factorization now becomes your x minus a times a minus 1 times x minus a plus 2. Okay, this middle term is very convoluted, but it can be resolved into factors. Okay, this looks very clumsy and complicated, but this can be resolved into factors. When you have factorized it, we can now equate both factors to 0. So either x is equal to a, or your a minus 1 times x is equal to a plus 2, which implies that x is equal to a plus 2 upon a minus 1. Okay, this is from the first equation, right? First equation. Now since 1 and 2 are exactly identical but just different in terms of the constants a and b. Okay, if I solve for a and I get this expression, if I solve this second equation which is in b, I'll get the exactly same expressions, right? So since equations 1 and 2 are identical but differ in constants, that is a and b are different, differ only in constants a and b. Therefore Therefore, solving equation 2, we will get either x equal to b, or x will be equal to, from here, it will be b plus 2 upon b minus 1. Okay. So these are the four roots from these two equations. Okay. Now it is given that there is exactly one common root. So let us first write the roots. Okay. The roots from equation 1 are a or a plus 2 upon a minus 1. And from equation 2, the roots are b or b plus 2 upon b minus 1. Okay. These are the roots. Now the thing is, it is given, it has exactly one common root, and it is given that a and b are different, right? That is a not equal to b. So the common root cannot be a equal to b, right? Because these two are given to be different, so we cannot equate a and b together. Okay. Similarly, this expression and this expression, these are also exactly identical. So if we equate these two, we will again get back a equal to b. So for common root to be different, for common root for common root which is true when a not equal to b, we can have a equal to b plus 2 by b minus 1, or we can have this b equal to a plus 2 by a minus 1. Okay. This cannot be either a equal to b or these two, because these two are different, right? You cannot equate these two, and these two expressions are also equal. So if we equate these two, we'll again get a equal to b, which is given to be not true. Okay. So in order to get a common root, we have to equate either a equal to b plus 2 upon b minus 1, or we have to equate this b equal to a plus 2 upon a minus 1. Both are same. Okay. Both will give you a condition, but you cannot equate those a equal to b or that one. Okay. So if I proceed with this one and cross multiply, this will imply ab minus a will be equal to b plus 2. Okay. So if I bring the terms to one side, ab minus a minus b is equal to 2, right? So can anything be taken common here? Can this be factorized? A b minus a minus b. Well, if I add 1 to both sides, then it looks like this will become 3, right? So now if I take a common, this will become b minus 1, and minus 1 common. So this becomes b minus 1 times your here a and minus 1, a minus 1. Okay. This becomes equal to 3. So now this 3 can be written as 3 times 1 or 1 times 3. So from here we can conclude either b minus 1 equal to 1 and a minus 1 equal to 3, or we can have b minus 1 equal to 3 and a minus 1 equal to 1, right? These are the two combinations. So from here we get b equal to 2 and a equal to 4, or else we get b equal to 4 and a equal to 2. Okay. So these are the two combinations we get. Now we have to find the value of a to the power b plus b to the power a upon a to the power minus b plus b to the power minus a. So after a bit simplifying, this becomes 1 upon a to the power b plus 1 upon b raised to the power a. So on further simplifying, this implies that in the here it will become a to the power b plus b to the power a divided by a to the power b times b to the power a, right? So this and this will get cancelled out, and we are left with a to the power b times b to the power a. Okay. Now your a is 4 or 2 and b is 2 or 4, okay, respectively. So taking a equal to 4 and b equal to 2, this becomes 4 to the power 2 and b is 2 to the power 4. This is same if I take the other combination also, okay? Then this will become 2 to the power 4 and this will become 4 to the power 2, okay? So this becomes 16 times 16. So 16 square is 256, right? So this is your final answer, 256, okay? So from the start, it was given that a and b were two different positive integers and two quadratic equations were given, and in order which have exactly one common root, and in order to factorize I had to break down the product of this quadratic equation, product of roots and the sum of roots, and had to find the linear factors, right? So that was a very clumsy and complicated part, but after that it is relatively easy, okay? And the other part is that since the equations are identical but differing only in constants, the roots of first equation in terms of a will be identical, but it will be expressed in terms of b for the second equation, okay? And for the single common root condition and a not equal to b, we have to equate either this a with this expression, or we have to equate this b with this a plus 2 minus a plus 2 divided by a minus 1 expression, okay? So from there, if with further simplifying, we get this product a minus 1 times b minus 1 equal to 3, which can be either 3 times 1 or 1 times 3. Okay, so from there we get either a is 4, b is 2, or we get a is 2, b is 4. Either way, this product comes out to be equal to 256. Okay, so this is the final answer. This is a bit slightly tricky. This middle term part is very, very convoluted. This took me some time. Other than that, the rest part is not so hard. Okay, this middle term is a bit tricky in my opinion. Okay, so this is it. If you have any doubt, you can highlight in the comments. Okay, thank you.